Welcome back everyone, Corey Anderson here. Today I'm going to go over with you some basic terminology for exercising. So, get out your pen and paper. You're going to want to write these down. These have a lot to do with your body movements and also body studying, the science of how your body works. Okay, so the first one will be biomechanics. Okay, biomechanics. Okay, and biomechanics is science concerned with the internal and external forces acting on the human body. Number 2 is superior. Superior is superior, and it is positioned above a point of reference. So, let me put an illustration. We have this dot right here. Superior would be above that point of reference. Okay, and the next is inferior, which is positioned below a point of reference. So inferior would be found on the bottom. Okay, then proximal, position nearest the center of the body or point of reference. So proximal would be closest to that point. Okay, then distal, position farthest from the center of the body or point of reference. So distal would be way over here. So if we had two lines on this side, or two dots right here and one dot right here, this one would be the proximal, this one would be the distal. Okay, now anterior. Anterior is located on the front of the body. So let's say this paper, it's a body. This side you're seeing right now is the anterior view. Okay, the next is posterior on the back of side. So this side would be the posterior side. Okay, so the back side is your posterior. Next you have the medial, which is positioned near the middle of the body. Position near the middle. Okay, medial, and which one is proximal is very similar. Proximal and distal are closely related, while medial and lateral are closely related. As we move further on, you guys will understand it more. Okay, then lateral, towards the outside of the body. Okay, so let's say a lateral movement. You bring your shoulders. I said rotator cuff. They're called rotator cuffs. They say your shoulders or your deltoids. You bring it up. It's a lateral movement because you're moving it away from the body, from the side. Okay. Then contralateral, position on the opposite side of the body. So this deltoid is contralateral to this deltoid. They're opposites. Next is ipsilateral, positioned on the same side of the body. So your deltoid and your left arm are ipsilateral with each other. They're on the same side. Next is the anatomic position, which is basically just the position with the body erect, arms at the side with palms forward. So anatomic position is just basically you standing like this. It's the position that everyone uses when it comes to identifying certain things within the human body, such as posture and movement and motion. This is the basis of all of that. So next is the sagittal plane, imaginary bisector that divides the body into left and right halves. So the sagittal plane, take an imaginary line and put it all the way down through the center of your body. That plane right there is the sagittal plane because it separates the body from left and right halves. Okay, so next we have flexion, which is bending movement in which the angle between two segments decreases. So let's say you have your arm. When you flex it, you are bending the angle. You're shortening the angle between the two adjacent lines, and it's causing your muscle to contract. Okay. Next you have extension, which is the straightening movement where the relative angles between two segments increases. Okay, so this is flexion and this is extension. Okay, next we have hyperextension, which is the extension of a joint beyond the normal range of limit. So hyperextension, let's say you bring your arm as far as it goes. When you hyperextend it, you're pushing it farther than it's originally supposed to go. And we're going to go over this thing. It's called a autogenic inhibition. When you are in that hyperextensive, your body has its own protective system to keep your muscles from tearing and keeping your arm from getting injured very badly. Okay. Next we have the frontal plane, which is the imaginary bisector that divides the body into front and back halves. So the frontal plane runs down to the sides, okay, because it's dividing the body between the front and the back halves. Remember, the anterior and the posterior. Okay. Next we have abduction. Abduction is the movement in the frontal plane away from the body. Okay, so in the frontal plane away from the body, it would be basically that lateral movement that we talked about with the shoulder. When you bring your shoulder up, it's a lateral movement because you're moving it away from the midline of the body, and it's abduction because it's moving away from the midline of the body. Okay? Movement in the frontal plane away from the body. We're going to learn about all these movements when we go over the biomechanics, which is the study of the human movement system, and we'll get into detail with that later. Next we have adduction, which is movement in the frontal plane towards the body. So bringing your arm back down, that is adduction, okay, because you're bringing it back to your center. Next we have the transverse plane, which is the imaginary bisector that divides the body into top and bottom halves. Okay, so the sagittal plane, the transverse plane runs along the lines right here, and it's what divides the body between the top and the bottom halves. Most of your bodily movements will be, when it comes to rotations, is in the transverse plane. Okay. Next we have internal rotation, which is rotation of a joint towards the midline of the body. So rotation of a joint, kind of, you're rotating your joints inward. Okay, you're moving your, let's say, your knees. You're bringing your knees inward. Okay, your joints are coming in together, and that would be internal rotation. External rotation is a rotation of a joint away from the midline of the body. We'll use the rotator cuff for this example because it's a lot more easier and it goes with it a lot better. Okay, so internal rotation is movement of a joint towards the midline of the body, and then our external rotation is movement away from the body. So forward is internal rotation, and then back is external rotation. Okay, next we have horizontal abduction, which is movement of the arm or thigh in the transverse plane away from the anterior position to the lateral position. So basically that means, you have your arm here at the side. When you horizontally abduct it, okay, we'll start from here. When you abduct it, you are moving it this way, and it's in the transverse plane. Remember, the transverse plane is the one that deals with rotation. So you're rotating your arm from the front to the side of you, and that's horizontal abduction. Next we have the horizontal adduction, which is the opposite. You're moving it from the side to the front of your body. Okay. Next we have scapular retraction. Now, your shoulder blades, these are your scapular. You have muscles known as you have your rhomboids, you have your upper and lower upper traps, middle traps, your teres major, a lot of muscles that come into movement when it comes to moving your scapula. Okay, so you have the first one, we have scapular retraction, which the shoulder blades move towards the midline. Okay, so it's when you bring them in like that. So remember, the midline is the center. So when you're retracting, you're bringing your shoulder blades in towards the center. Okay, next we have scapular protraction, which is the shoulder blades move away from the midline of the body. So you're having retraction, you have to protract it. So you're bringing them outward. Okay? Next is scapular depression, which is the shoulder blades move downward in the inferior position. You bring them from the center and you're bringing them down. Okay? That's scapular depression. And then next is scapular elevation, which is moving upward towards the superior position, and you're bringing them up. Okay? So, retraction, protraction, depression, elevation. Okay? Next is concentric muscle actions. So, your muscles basically have three phases of motion. You have the concentric, which is the contracting of the muscle. You have the isometric, which is stabilization of that contraction. Then you have the eccentric muscle action, which is it extending. Okay? So eccentric muscle action is when muscle develops tension while lengthening. Okay, so extension, eccentric. Okay, next is the concentric muscle action. This is when exerting force greater than resistive force, resulting in shortening of the muscle. Basically meaning, let's say you have a 5-pound weight and you're lifting it up. You're in the concentric phase because the force that your muscles are producing is greater than the force that the weight is developing against you. Okay? The next you have the isometric, which is the stabilization of that weight. And it is a muscle exerting force equal to the resistive force, causing no change in the length of muscle. Okay, so let's say you have the weight, you're in the concentric, you start your eccentric motion, then you stop it in the middle. Okay, that's isometric. Okay, that's the first 31. Okay, now we have 15 more to go. Won't be too long. Okay, the next one we have is force. Now force is just influence applied by one object to another. If you haven't taken any physics class, we learn about force. You know, it's how God works with his natural laws in the physical world. A force is when, you know, I drop this calculator in my hand. It's producing a force when it hits, and that's kinetic energy. And I won't get into all of that right now. We'll save that for another video. But actually, you know what? I will share that with you right now. Okay, so when this calculator is up, this is in physics. It's at 100% potential energy. Then when it's being released and when it hits, it's 100% kinetic energy because it's in motion. Okay? Now next is the length-tension relationship. The resting length of a muscle and the tension it can produce. So length-tension relationship, you know, you have your weight. Say this pine cone is our weight. And our arm is at its full length. That's the length-tension relationship. Okay? The next is force couple, which is two or more muscle groups working together to produce movement. Okay, so two or more muscle groups. Let's say, I need an example for this one. Two or more muscle groups working together to produce movement. Okay, I have a good one. Let's say you're doing a bench press. You know, not only are you using your chest, but you're also using your deltoids to push that bench upward. And not only that, but you're also using your what are they called? Your triceps. You're also using your triceps. They're your secondary muscles. When you're Pectoralis, or your chest, it's called pectoralis major and pectoralis minor, so you have two divisions within the chest. When these are exhausted and worn out, these ones start to come into play. They help the chest push that bench up, the weight, the barbell. And then when those two are winded, your triceps come into play to help them get that muscle action into play. Okay? Next we have rotary motion, which is movement of the bones around a joint. Like your rotator cuff, it's a rotary motion. Your bones are moving around that joint. And remember, when we went over the joints, the synovial joints, your rotator cuff has the most synovial fluid in it because it is the only joint in the body that has full access and it can move into all three planes of motion. Now remember, the planes of motions are the sagittal plane, the frontal plane, and the transverse plane. Okay, so next we have a torque. A torque is a force that produces tension. A torque is a force that produces rotation. So when you are rotating your rotator cuffs, you're producing a torque because it is that rotary motion. Okay, now we're going to go over into behavioral patterns, how your body develops, okay, when it comes to certain movements and repeated patterns. Okay, so motor behavior. Motor behavior is a motor response to internal and external stimuli. And basically what a motor response is basically your body's ability to respond to certain circumstances and situations. Okay? Motor control. How the central nervous system, remember the central nervous consists of the brain and spinal cord. Okay, how the central nervous system integrates internal and external sensory information with previous experience to produce a motor response. Okay, now it's saying here how it integrates internal and external, sensory information. Not only does your central nervous system take in what's happening on the outside, but it is also interpreting what's going on the inside of your body. Okay? And it is this motor control that the central nervous system brings information from previous experience that it has had to produce a proper response into the situation you are in now. Okay? Motor learning. Motor learning is the integration of motor control processes through practice and experience. You have to create that habit. You're building that habit. It's you have to train your muscles to move in a certain way. Okay, that's what motor learning is. When you take everything you get from motor control and you're putting it into play. Okay? Next is motor development, which is the change in motor skill behavior over time. Okay? The change in motor skill behavior over time. That is when it becomes permanent and it becomes a habit. Okay, muscle synergies. Muscle synergies is a group of muscles recruited by the central nervous system to work together for movement. Okay? So basically, your muscle synergies is the result of your central nervous system recruiting the certain muscles for a certain movement. So when you're doing a bicep curl, your muscles are not only recruiting all the bicep stimuli that it needs, but it may also be using, that's basically it. For that bicep movement, that's all it is that concentric muscle action. Okay? So, proprioception. Now, proprioception is very important, especially when it comes to training your physical body. You have to train your balance system. It's your mechanoreceptors. They have these things called mechanoreceptors. We learned that in the nervous system. If you guys haven't gone over that video yet with me, go over. Feel free to watch it. I encourage you to watch it. But mechanoreceptors are your body's touch receptors. It's how your central nervous system can interpret what is happening, with your fingers going across your skin. And basically, proprioception is your central nervous system's ability to sense its balance in the external world. Okay? So, good proprioception training would involve unbalanced or unstationary environments, such as on a Bosu ball. And I'll explain all that stuff later. Okay, right now we're just going over the terminology that is very important for you to have, because it will help you along in these videos. Okay, next we have the sensory motor integration, which is the cooperation of the nervous system and muscular system to produce feedback. Now remember, your body has this thing, it's called a kinetic chain, because your body uses the central nervous system, your muscles, and the skeletal system in order to produce movement. All three of these work together. They're all integrated with each other. And if any of these are lacking, or if any of these aren't up to par with each other, then it's going to definitely affect all the other functions of the body. So sensory motor information is the communication between your nervous system and your muscular system. Okay? Feedback. Feedback is the use of sensory information and sensory motor information to help the human movement system in motor learning. Okay, so feedback, your body's giving you feedback on its balance. Okay, it's not balanced. So what it does is it uses its sensory motor information to recruit the proper muscles to bring your balance back into par, so you don't fall. Okay, so internal feedback is the body uses sensory information to reactively monitor movement, which sensory information comes from within. Your body is interpreting its internal environment, like with that proprioception, the balance, to recruit the proper muscles. And then the external feedbacks, the body uses external information, standing on that Bosu ball, to provide by outside forces. An example of this could be a trainer. Okay. Let me rephrase these two. Internal feedback is if you feel that, say you're doing a squat. When you do a squat, you should feel it not only in your glutes, but in your quadriceps and in your hamstrings. If you feel it more in your hamstrings, you're not using your glutes enough. Okay, that's an example of internal feedback. External feedback is someone telling you, hey, you should feel it right here. If you don't feel it right here, okay, you need to bring your posture back up a little, or you need to lean forward a little bit. Okay, that's external feedback, when you're relying on an external environment to help you in your endeavor. Okay, so that concludes it for our basic terminology. I hope you had your pen and paper out, and I hope you wrote it down, because it's very important before we move on into our human body learning. Okay, so I hope you guys enjoyed this video, guys and girls. If you liked it, please subscribe, and if you liked it, please share. I'll see you guys in the next one. Take care.